to do is follow up on what I talked about yesterday when I spelt out, when I showed you an architecture for scaling API usage and for ensuring that it's enterprise grade. It's just a buzzword, but what I mean by that is it's secure when you expose your intellectual property through data, and that you can give out as a company or as a systems integrator working for a company, you can give out data that you know to be secure, to be locked down, to be privatized where it needs to be, and to do that in a kind of a continuous manner, a sustainable manner, without having to grow massive infrastructure, massive ESBs in the back end, and really strain your existing architectures. Just to reiterate where I got to yesterday, there's sort of three critical points here that that Intel is behind and pushing in the industry, but are also movements within API development and API management. The three components that that I'm certainly caring about are HTML5 based application development, the usage of gateways rather than exposing enterprise service buses or having really limited protection via routers and firewalls. And then the tie-in with APIs that are protected at gateway level to Portal. And this tie-in is now really, really crucial, because what we used to have was, well, when I started in data interchange, it was X500. And you were on your own. What we used to have was this move to SOA, and Portal used to be directories, UDDI, and we all know the pain that that has. But the flexibility of having portals that are out there for anybody to sign up, and also the ability to place portals into wherever you need them to be, wherever is best for your company, whether it's online or locally within your own data center. So in connecting APIs, as I said, your gateway proxy is going to be giving you the types of capabilities that you can control service level agreements, you can control API usage. It's the point where you're going to be making decisions about not only allowing somebody in, but the charging for where or what they're using. So implementing monetization policies. It's also going to be your threat prevention mechanism. Don't forget that at gateway, at router, at switch, at firewall level, you haven't got a whole message to examine. So what you can't do are make good decisions about the message content to make sure it's worth spending processing power on dealing with that messaging. And you're avoiding the cost of having that go to your back end where you find that the content or the authentication will fail. And it's far more expensive in compute resources dealing with document object models for JSON and document object models for XML, and having them fail there on an enterprise service bus when you're being charged by the core licensing. Portal. So the portal really is not that crucial when it comes to connecting APIs. It's where you connect developers to APIs. And I'm not going to spend too much time on Portal this morning, because it's more about the individual components that you need to be implementing as a company or as an enterprise when your data gets put out there. So most companies that we go around and talk to, and I'm sure it's true for yourselves, you've got a history. You've got a back end that you've inherited, that you've cobbled together through acquisition, that you've rationalized since then. But it's going to be places where you store data, very, very heterogeneous usually. I was in at one credit card agency just a couple of months ago, and for 2,000 employees they have 400 applications, 150 of which they needed to secure. So that's sometimes the scale of things that you're facing. I've just got 4 systems of record on the back end here, so I'm kind of going easy on myself. But certainly companies are giving out their intellectual property through data, through customer management systems, customer records. Directory comes in there because the identity of who you're talking to is important. And a number of different ways of exposing that. SOAP through to SQL and MQ are common, but we see far more esoteric things, TCP to devices coming on. Don't forget that for significant numbers of industries, their sources of data are going to cost a lot to upgrade. So they may be modified. So sensor data needs to be modified and made available over TCP/IP. That's happening in hospitals that we see in Intel in the healthcare sphere. It may be happening in traffic as well. I can only speak to hospital data, and that's going to be a huge source of scaling of API usage when hospitals and healthcare authorities get their act together. You've got to get that out with pretty much JSON, REST, basic HTTP authentication and OAuth out into the usable world. What are the connectivity points that you need to put in between in order to manage that API or collection of APIs? On top of that, what do you have as an authentication mechanism now? What do you need to get it to make it usable, to have that developer-friendly experience, or to know and track who you're dealing with, who's making requests? And here you're going from existing sort of enterprise authentication, which is if you're getting your act together as an enterprise, it's kind of going to be SAML WS security based. If you've got technology that's kind of getting on for 10 years old, it needs to map over and to be able to map identities, track them through coming from an API key externally to a SAML assertion, name from a SAML token, or Kerberos, for example. So there's those concerns on top as well. I'm going to kind of just sort of break here and make a bit of a segue. It was a bit of a discovery finding the proper spelling of segue a few days ago. The reason I'm making this kind of break from the path of what I'm talking about is because very, very heterogeneous development environment for apps at the moment. And this really has an impact on the connectivity. So imagine you're an iOS developer, an Android developer. You may be using in-house tools, you may be using Adobe tools, different sets of SDKs for that. They all have different ways of addressing OAuth, of addressing JSON, JSON-P, creating requests and handling the back and forth of requests. And what this means is that, I guess the guys from Smart Bear, SOAP UI, it's kind of meaning that you've got this heterogeneity, this set of differences, with the number of ways that a request can be formulated, and a series of requests can go back, and AJAX can be used between the point where the API is exposed and whichever device is going to have to handle that. The big three, you're showing those differences that then kind of lock you into that kind of development cycle for each one. And the testing is multiplied simply because you've got different environments, different SDKs. And the request might look different, and it's just kind of legwork. It's boring. What certainly Intel is pushing, what a number of other tools are out there in the industry at the moment are capable of, is taking advantage of this common support for HTML5 that's available on all the platforms. And my kind of plea is, my sort of kind of wish is that we, as an industry or as individuals, move away from I'm an Android developer and I'll publish to Play, and start using the HTML tools that are out there, just to make your life easier. Typically, your web applications and what's limiting uptake of HTML5 is the kind of view that you've not been able to take advantage of all of the device's capabilities. That's not so with HTML5 development environments at the moment. I can talk more about that at the stand. I'm just round the corner. But what you should be looking for are tools that allow you to develop, that are going to be providing an environment to automatically create your cascading style sheets, to automatically allow you to debug, emulate a number of different devices so that you can make sure that your apps look the same on tablets, phones, web applications. But also that emulation means that you can check in the back end through debugging, in environment debugging, whether your requests are behaving the same. And the deployment should be packaged in there so that you can build for iTunes, you can build for iOS, you can build for Android, you can build for Windows 8.1, you can build for Windows RT, and BlackBerry. Has anybody got a BlackBerry anymore? They're all in the bin. Oops. So, having made that kind of plea for HTML5, and really asserting that, if you use that framework for development of, certainly for enterprise company apps, it makes it suitable for bring your own device. You can give that kind of freedom to your employees, and you're not giving yourself a massive support headache in dealing with different types of JSON requests coming through, and different looks and different ways of operating for essentially the same app. What I wanted to talk you through was using kind of an internal use case that we have in Intel, where we have a room finder, and this was kind of sort of brought together in an afternoon, really, as employees in is it up there? No, Jones Farm. So Jones Farm in Oregon is a big US Intel fab plant, and employees thought finding rooms is traumatic. You've got to go onto this old, it only works in Internet Explorer. You've got to have your computer open to find and kind of book a room. So we've got a kind of a siloed legacy application. It's kind of a bit hard to get to because you've got to have a computer open for it. That nicely ties in with kind of room sensors that show whether you've got kind of a meeting going on in the room or not. And at Intel, we're actually quite a free organisation. You can, within reason, have quite a large choice of devices that Intel IT will support and maintain for you. So that had to be brought together, very, very quickly for all sorts of devices. And we did that with Gateway, mashing up the legacy data. So Gateway was exposing that legacy data, along with HTML5 development of a relatively simple interface. But it did allow employees to be walking around as they're trying to find a room to have a set-down meeting in, to do it very, very quickly without having to go to their own cubicle. It's an example of, I said it in the last meeting, I'll say it again, eating your own dog food, which is kind of an English phrase. If your own product is not good enough for use in your own company, it's not good enough for use elsewhere either. So, I guess this afternoon of development gave us the Room Finder app. The Room Finder app we developed in an Intel tool that's available for free download. It's an open source development environment for HTML5 on mobile phones. I don't think anybody will accuse me of plugging anything for free. Or am I for it later on, Jacob? I'm for it, okay. What we can't get you away from is actually having to code the JavaScript and customize some of the cascading style sheets there, but there are numbers of tools out there that will allow you to do that. So, here we see the app with a bit of graphical representation. I'm not going to show you that live at the moment, simply because it wouldn't show you anything but free rooms, because nobody's awake on the west coast of the US at the moment. But because that data needs to be exposed both within the factory and for people that are maybe visiting and aren't necessarily dialed into the VPN, it needs to be externally available as well. So here we've got on the gateway component this connectivity side of things, where you've got to secure the interface and deal with that data in and outflow as it interacts with the legacy components behind, and that was database, SQL database was storing room components, and the original web application was CGI, Perl, or PHP, something like that. So again, your tools of choice here should not involve coding for something that is relatively understood and something that should be easy to accomplish. So coding for external API protection in Java or a scripting language, even in sort of ready-built frameworks like Groovy, Grails, Ruby as well. The coding should not be a requirement. It should be visual configuration, because we're dealing with standards here. Vaguely OAuth standards, emerging OAuth standards, I should say. But also back-end, well understood, well documented standards like WS security, and so forth. Because it's understood, you can visually script it. So somebody else has done the hard work for you. Because it's externally available, you care about the content that you receive. Content attack prevention is kind of first up. That's a lie, because my slide says how to receive and invoke information. So I'll talk about that for a while. Essentially, you can do all of this stuff and have been doing all of this stuff with Apache Camel, and you can build ESBs out of that kind of thing. But it takes months or weeks, rather than half an afternoon. But as you receive and invoke data in and out of gateways, then what you're looking to be able to do is load balance, is handle the difference between synchronous and asynchronous. Don't forget that although you might be connecting with a synchronous REST HTTP API, what the backend might have is WebSphere MQ6 or JDBC over to a SQL database, or HTTP to a NoSQL database or some type of in-memory data grid. That's not something you want to start connecting bits of code up to do so that it's all synchronous JSON HTTP. So the ability to decouple how you receive the message, how long you're waiting to correlate a reply back from message-oriented middleware, that ability to decouple enterprise integration patterns, if I remember a few books back, is very important. The ability also to bundle web sockets on is very, very interesting as well. We see reasonable throughput and performance advantages with bundling web sockets on top of HTTP, particularly with telcos. So telcos need to talk to set-top boxes, and media companies need to talk to set-top boxes. Maintaining those connections gives you some idea of what's happening out at those set-top boxes, reduces latency of communication. And I'm sure the same is true for going out to applications that are mass use applications on mobile devices. Now we talk about content attack prevention. Very important to trust what's coming over. Once you've advertised something on a portal, people are going to want to connect to it, assuming they've found your portal. And in connecting to it, you may attract the wrong kind of attention. And there are various sort of levels of attack. But what you want to be able to start to do is separate the wheat from the chaff, the good requests from the bad requests. So you look at tools for restricting how HTTP communicates, what methods are allowed over HTTP, what URIs, what query parameters, regular expression search on all of that kind of thing. And then you bolster that. This is my running count of mad names for different types of JSON and XML type attacks, either content-based or schema-based, document type definition-based type attacks. There's quite a few of them, and yes, the argument is that your JSON, your XML parser in the back end is probably going to be all right if they receive those. There's been years of debugging on them, but the real problem is what kind of computer memory resource have you got to stand up for it to deal with that kind of stuff coming through? And the gateway is the place where you need to be dealing with that, not your application server. Once you've kind of constrained what's coming through as you connect through APIs, you care about who. So get rid of what's wrong with messages before you establish who's connecting. This is a second layer of protection. So here, you can see I'm sending over with HTTP OAuth authorization. We've got that tied in with our SAML internally within Intel IT. So I'm able to map OAuth and persist that as a SAML assertion internally within the company. Again, certainly from the client side, it shouldn't be all that much problem. And we saw that with companies like, or presentations and demos like OAuth.io, that it shouldn't be too difficult to deal with. Quality of service. The gateway is the place to be dealing with messaging spikes of 200 per second when you can only deal with 10 per second on the back end. So queue up, buffer those queries on the gateway. Do that across clusters, because you've got this on portal in multiple data centers. Enforce those developer limits and those monetization limits across multiple data centers as well. And then give yourself the ability to talk to these legacy applications. So you should be looking at parsing JSON to XML, to any other data format as well. Visual JSON mapping, tokenization of personal data, format preserving encryption of personal data. And you should be able to do that visually, because the tools have been around for years to do that kind of thing without having to worry about going deep into XSLT2 and coding it. Just to kind of round off, it's a relatively traditional two-tier structure of connectivity through gateways to leave your application servers free to do the business logic where it costs more to do the computing. I'm available outside in one of the booths. There's a big Intel sign there. Happy to have a conversation, although all of my papers were stuck in the post, so I can't give any papers out. Or freebies, unfortunately. Thanks for listening, particularly as soon as it was the graveyard shift after lunch. Cheers.